Jullie zijn er dus.
Good morning, everybody.
Okay.
Good morning.
Ready to start?
Yes, I think we're ready to start.
Okay.
So if everybody is in.
Let's see.
We can't see the number of visitors, can we? It says 1.
So Eric, if you could give a small introduction on SmartThings.
Yeah, I will introduce a little bit. Okay, welcome all this morning, the 5th day of our SmartThings training school. So SmartThings are a project on smart repair and self-healing of concrete structures. This is the 5th day, and the plan was for today to go to Concrefy, a company in the Netherlands that is partner in SmartThings. They will have us today, not physically, but everything is online, as you know. We have people from Concrefy giving us a presentation of what they do, what the company is, and then what kind of research they do. And the first person to do that is Toine van Casteren. He is director of Concrefy. You see him already in the screen. And after that, also Andrea Blagijevic, who is head of research. He will give us some insights in the type of projects they will do. So, Toine, the floor is yours. Tell us what Concrefy is.
Thank you very much. And immediately I hand it over to Erik Verhoeven. It's also Eric.
Yeah, just to make things easy for us all. Short introduction of myself, or my role here, not myself, but my role. We're going to try to make this a bit interactive. The plan originally was that you would all be here on our premises. That would make things way easier. But you are there now, a bit remote. But you can talk to us, you can see us, so we hope to make this a bit interactive. So please raise your hand, ask questions, and make sure that at the end of this morning, you know everything you want to know about us, our company, and about our projects. So Toine is going to do a short presentation. You can interrupt him, wave your hand, and we can ask questions. So please stay with us and be part of this instead of just being a spectator. So Toine, first question to you, of course, is can you introduce yourself?
Okay, I'd like to do that. I have a special connection with the University of Delft. I'm a son of a contractor, and I did my studies in Delft. I'm a civil engineer, a concrete specialist, and I started my own company after being for a few years on an international building company, YBC. I started 26 years ago with this company. At that time it was named BAS Research and Technology. Today we call it Concrefy because over time we got more international, and now we are selling our services and products in 72 countries. So quite international, you could say.
Yeah, you automatically more or less went from yourself to the company.
Yeah, that's my problem. I'm so long in this company that is more or less a part of me, you know. And then, so if you talk to me, you talk to the company, vice versa.
Exactly.
Yeah. So that's when you, you're at the start of your career, I would say. When you're in this industry for 26 years, you get connected with it, and it will never let you go. So that's my small introduction of myself.
Okay, that's the person, Toine van Casteren, Managing Director of Concrefy. Any questions about Toine as a person? He is married, 3 children, these kind of things.
Yeah, and I have too
Whatever
much
you want
hobbies.
to know. Otherwise, we'll just go immediately to Toine telling a rough outline of the company, give you a presentation.
Yeah.
Perhaps a bit of short tour as well.
Yeah, if you can zoom in.
I'll zoom in the presentation.
So in this overview, you can see the startup in 1994. I started with a very small lab. In 1999, it grew a bit bigger, and at that time already we had the most modern, industrial lab in the Netherlands. And since 2007, we have our lab facility in Venlo. And at this time, now it's the most modern and largest practical lab in the Netherlands, you could say. And I have a small video tour that I would like to give you, in fact, today, but now we do it virtually. So now you see our premises. This is how our customers and you could enter our building. As you can see here, we have about 3,000 square meters of lab facility. We are very practically organized. And we have our control rooms where we see all kind of sensor data coming to us on a global scale. So many international projects that are being controlled by us. Of course, we have a dynamic team where we combine concrete technology, test results, and also digital services. Here you can see a small overview of what we do, all kind of stuff related to raw materials, fresh concrete, hardened concrete, damage expertise, factory production control. We have all kind of facilities to do research on all kind of new concretes, like self-healing, self-compacting concrete, high strength, low strength, and we combine all these things, you know, so testing, consult, and research and development on rebars, fiber concrete, and all kinds of types. So everything that is connected to concrete is being tested by Concrefy. And sometimes it starts with sand or gravel, and also rebars. We do that on an international scale. So even for big dams, big bridges, we see all kinds of samples coming. And what you see here is an overview of also not only concrete technology, but also new sensors. So we develop our own sensors and we connect it directly, as you see in this video, with our daily business and our daily consult and reporting. And we also consult precasters and building sites. So what you see here is that our people with mobile labs go on site and they check all kind of factory production control stuff. And we have also very modern test devices for high frequency pulsators. So we do that for big dams, for earthquake testing on rebars and couplers.
So anybody, any questions? Because now you've seen the lab, you've been there. We're going to elaborate on it, of course, but do you have any specific questions about what you've seen or remarks to make?
But for me, it's important that I know what you've seen, because
That's what you see.
so you see the video right now. So there's a
time
Nou
lapse.
is het video gewoon afgelopen.
No, we see you now.
okay. Yeah. So I'm there's a, how do you say that? A delay in the line, I guess. Yeah? Let's.
There's a delay in the live stream. The live stream is about 20 seconds later. What we see you live, so we hear you live.
Okay. And you see
fine.
some. Okay, then yeah. Well, no problem. We try to solve it in a few minutes. If I have a next video, there's only next. Yeah, because.
It works. Yeah, well.
But you see me live now.
Yeah. We see you.
See it, that's one.
Okay,
This is what we
great.
see.
Yeah, okay. Well, then let's zoom into this video of this screen, Eric.
Yeah, so no questions to ask, then we go back to the presentation to look at the environment in which we operate.
Yeah. Well, here you see,
And you as well, by the way.
here you see how our company works. So we have different divisions, you could say. So the first division is testing. We have an accredited lab in the Netherlands. So accreditation is the highest international standard, I would say, for lab facilities like ours. We have a consult department where our concrete technologists advise our customers. That can be contractors, producers, but also engineering companies and consultants. And we have what we call a Concremode division. And Concremode is real-time measurement with all kind of new sensors. So we combine sensing and concrete technology, and that's what we call Concremode. Concrete, remote, Concremode. You will hear that much more later on.
At least we hope.
Exactly. Maybe a bit slower than I thought, but so our strategy, our philosophy is that we have sensors on site so that we have real-time information on these building sites and we can help our customer in real time, and he has all kind of data also available, because that's a problem in our industry. It's quite traditional, old-fashioned, you could say, but we need to industrialize. Our productivity in the industry is very low. It's poor if you relate it to other industries like chemical, food industry, and that kind of stuff. So that's where we, if you connect it to automotive, we have a big problem, you could say. So and we think that digitization, internet, industrial Internet of Things, sensing, remote technology, digital services is the solution to bring our smart technology to the industry. So that's what we do here, and we think that the precast industry reflects the industry on site of tomorrow. If you introduce new technology in the precast industry, then you can export it to the sites. In the precast surroundings, you produce under good conditions. You can optimize your production, and I think that in 15 years a production site looks more or less the same as a precast plant today. And to develop that, we have a department, R&D and digital services. So our R&D people, they focus very much on the combination of digital services and concrete technology. So here you see the departments, the focuses. So that's research and development, forensic engineering, applied concrete technology, and remote sensing. Well, if I show you some examples, we focus very much on compressor strength, optimization of the strength, high strength concrete, all kind of self-compacting concrete. In the end, we try to help the consultants to reduce the volume of their structures. So in the end, you should be able to produce a concrete beam in the profile of a steel beam. Because if you look at the goals of today, reduction of energy, reduction of CO2, is also connected to more intelligent engineering. Smaller structures, less rebars, high performance concrete, and a process optimization so that you have exactly the right strength, nothing more, nothing less. Industrialization. And well, we focus very much on that in our R&D. If you look at our forensic department, due to our technology and our knowledge that we know what's happening in the industry, people ask us to help them, to consult them on damages. And we use that experience to improve materials and the processes. So we connect it to our daily business. And this is what you see, what we do in these, in a normal daily practice. Here you see self-compacting concrete, but we have implemented it about 22 years ago already in about 20 factories in the Netherlands. And today, 70% of our precasters work according self-compacting concrete procedures, and that's very good on an international scale. So we are very, you said it.
You mean we in the Netherlands?
We in the Netherlands. So the Dutch industry is very well developed regarding self-compacting concrete. And if you go to Germany, it's only 4 kilometers away here from Venlo, nobody does it, at least just a few. So cultural stuff, cultures in countries are very important, whether they do or not adopt, adapt and improve this kind of technology. The Dutch people in our culture, we are quite open for new innovations, and as soon as we have a certain understanding of it and we have some trust in it, we immediately implement it in the industry and just learn by doing. In Germany, people just focus on the standardization, all kind of procedures, and then they start to implement. But as you can see with self-compacting concrete, it can last for more than 20 years. And that does not fit in our modern philosophy around regarding innovation. Concremode, as I said, is the combination of daily practice, concrete technology, and real-time data. Having the data means that you have control. That means that you have at least the opportunity to improve. Well, And that's more or less our company. And then you ask me, how do we?
Well, then I first ask everybody who's looking at us, if you have any questions, are you still with us? And it's understandable if you don't want to speak up in this group.
We are still here. I have a question.
Yeah, that's a good start.
So I understand that you do all the testing, you do the consulting, and you help contractors with projects. That I understand because you can immediately send an invoice to them. But how do you organize the developments? Because that's a challenge, I think, to the new developments. Who is going to pay for that? Because that's you have to do on your own.
You know, it's one of my goals for today because most of the people are quite young and they're in the beginning of their career. They theoretically oriented still. And I started like that, of course, 26 years or 30 years ago too. But it's my goal for this company to improve our industry, to make it better, faster, cheaper, with a higher standard to improve society, etc. But it's quite difficult in our industry because everybody in the R&D sector is focusing on quite reactive response to the industry. That means that in a company like ours, normally the most people focus on testing, and testing is reactive. Then you have some data. Yeah. But I really want to change, and I want to go proactive together with my customer to the solution. And therefore, I have put up this R&D development and this department. Partly it's financed by the invoices, as you said, that I send to my customers, and partly, we put all the finance and all the power and energy that we have in these new departments. And that's a bit a tough combination because you cannot spend millions on specific topics. So you have to really make a good focus, put all your energy, time, and money in 1 or 2 or 3 projects, and I would not say forget the rest, but at least focus on just a few topics. Mm-hmm. And that's what we did with remote sensing. I will show you in a few minutes how we developed, why we started with Concremode on compressor strength, because that's related to your question. I didn't have money, time, and energy to spend on 10 or 20 projects. I just picked low-hanging fruit for me and the industry.
Mm-hmm. Yeah.
It's a very good question, thank you. It also mirrors, of course, the environment the universities are in today. They have to finance a lot more than they used to, more or less the same as we are. Any other questions from the students, perhaps? Otherwise, no. Okay, no problem. Then we'll continue. And Eric and Toine were almost discussing already how we are going to do this and who's going to pay for it. But first, let's take a bit of a step back and go to what exactly do we want to do? What's our vision? What's the vision from Concrefy on the future of the construction?
Okay. Well, first I want to give you a small insight in the industry, because it's quite important to know how this fantastic industry that we are focusing on looks like today. And there are some important changes going on in the mindset. That means if you look at the environmental paragraph, we don't talk about durability anymore. We focus on sustainability and even green deals on a global scale. And that's the higher goal, I would say. We don't talk about recycling. We talk about cradle to cradle and circular design. And we try to reduce energy and CO2. This month in November, we have the Concrete Society organizes a concrete event on a digital standard. And we have 4 topics like circular design, urbanization, CO2 reduction, and energy reduction. That is really important to our industry. But to go into this innovation, we must adopt prescription to performance. So it doesn't matter how much kilograms of cement, of sand, or gravel you use, or how your mix looks like. What is really important is what is the performance for the customer. And that is my career, and that is what Concrefy focuses on. Of course, we do research and together with universities, and we try to collaborate with them. But we focus very much on the transition to applied technology to make sure that my customer has a certain performance. And that's where the combination between our people and you can be very dynamic for the future. I think that we have to go to an open source collaboration on these kind of new topics. And also in the industry, some companies are doing this already, like Voorbijbeton, Van Wijnen, they are customers of ours. And they really want to open this, like we did 20 years ago with self-compacting concrete. People, companies working together. And we have to look for new materials, because cementitious materials, I think we have to change that. So we have to go to alternative binders, like we discussed today, is geopolymers, for instance. And but we have a problem on the way up, because we will have less fly ash, less quality of fly ash, and also less blast furnace slag cement, because the other industries are also improving. So we have to be very creative in future to develop all kind of stuff. And our industry is changing. That means we will have global urbanization. We need a higher productivity, higher standard of industrialization, CAD/CAM and BIM. And our precast industry will expand on a global scale very fast, because that will be the standard for the future. If you want to develop pricing, productivity, speed, then you really need to go to precast. So there's also a very high demand for smart technology combined with digital services. And that's where we focus on. And that's where we need intelligent people and research to make that happen. Because, as I said, precast reflects the building industry of tomorrow. And we think that you cannot longer focus on standards, because they are based on historical technology. We have to implement on in a new way, like design by testing. And that's where our lab comes in. If you really want to focus on design by testing, universities like TU Delft and Eric with his staff, and we have to focus on new implementation, learning by doing, you could say. So that's Dutch style.
And it has to be faster, of course, than it used to be. The development time that we had 20 years ago is no longer there. Every year you get a new smartphone, you get new developments.
Yeah, exactly.
Implementation of new technologies goes faster and faster, so you can't wait until standards are changed. Doesn't work anymore.
My personal idea is that if you look at the European and international standardization, I see more or less a standstill coming. People, company do not longer want to spend their precious time in how do you say that, procedures that last for 10 years to come up with a new standard. It doesn't make sense, because our economy develops much faster. The way you as students absorb all kind of new technologies, that's in a very, how do you say that, the speed, the acceleration with which you can generate all new technology, it doesn't fit in standardization. So I would say forget standardization, trust yourself, trust your new technology, and try to convince people on a scientific way, of course, of the added value. Yeah, well, you asked for my vision. That's our reason for existence, you could say, our raison d'être in French. So we want to be the concrete specialist as a company, but then in a modern way. The specialist does not mean that I have to know everything about concrete. No, I have to come up with a solution for our customer so that he has a partner and he has how do you say that, an institute that can help. Maybe in collaboration with you, with the university. That's this open source society. And our mission is combining digital services and smart modern concrete technology so that we can create added value. And create added value is just better, faster, cheaper, safer. Making money. If you don't make money with your solution, there's no chance. So our claim is fresh thinking for construction. It's quite fresh. Maybe not to you, because you're in the middle of all kind of new innovation, digitization and whatever. But our industry is quite far away from this new innovation. They're not digitalized. They're not industrialized. It's more, well, they're connected to manpower more than to industrialization and machinery.
Working the same way as 20 years ago or
Exactly.
40 years ago.
And that's the reason, and that's more and more people are a bit ashamed of concrete. Our president of the Concrete Society said it last year on the Concrete Day. We call it in Dutch betonschaamte. People more and more get a bit ashamed of using concrete due to the environmental problems, due to the massive volume of concrete, the enormous amount of material that you use, the CO2 that you produce, and the lack of creativity. You can be creative, but the industry is not creative yet, not creative enough. So we have to help them with new solutions. We have to give them input to improve. And our drive is that we want to convert unique selling points into unique buying reasons to convince your customer to adopt this kind of technology because they are quite far away.
It's going from a push to a pull.
Yeah. And what do we want to achieve? Better, safer, faster, cheaper. You can see here on large projects where we have worked, and we use high standardized concrete technology with real-time measurements to make these kind of projects happen and more creative.
Okay, again, a short check if you're all still with us. Any questions, remarks, whatever?
Okay, who starts?
The other side.
Who starts?
Or otherwise, just wave if you're with us still. That's probably not helpful.
Yeah.
People still listen. Thank you very much.
Yeah, I maybe have a question. I'm no longer a very early researcher. I'm a bit more a middle researcher, and I'm finishing my PhD, which is related to standardization. And I thought what you said was very, very inspiring. But how do you deal with this? Because, for example, I'm from Belgium, and here the government, which writes out these projects to build new structures, new buildings, always prescribes the BNOR certification, as I think you know.
Yes. Yes.
So this is a very standardized way of dealing with things. So what would your advice be to move beyond this very stringent code framework?
Okay, first of all, to get you back in your comfort zone, that there will be a new standardization does not mean that you won't have a job in the future. Moreover, I think we need a different type, a more modern approach. I'm also in the certification board of in the technology board of Kiwa. That's the biggest in the Netherlands. Like you said, BNOR. BNOR is a small institute. Kiwa is a big one. It's more commercial, and BNOR is less commercial. Nevertheless, they have the same approach. That means using international standards to create a certain certification process so that people do their factory production control. And as long as you are on track, you will have a certain certificate. But, and that's the problem in Brussels on a political scale, Brussels, that means Europe, wants to get away from certification procedures because they are nationally oriented, like you say, for Belgium, Germany, for the Netherlands, and they all have their own specific goals, very much related to marketing and commercial stuff of the industry. But Brussels just wants to focus on CE marking, so that's a producer's own declaration to get away from all kind of borders between countries, partners, and standards. So I think that we have to overcome this problem that standards take such a long time and are focused on national opportunities, but that you have an overall system that makes it possible that as soon as you have a new solution, that you can bring it to the market based upon research in universities practical applied research testing in practice, and learn by doing with your customer and your client together.
Yeah. Okay, thank you.
Okay.
Okay, thank you for the question. Other questions? Otherwise, we're going to some practical solutions that already are there, which we can show you, and Toine's going to share a number of them now.
Okay, yeah. I can tell you something about practical solutions, because this is how our industry looks like today. Yeah? So this is a picture of the North-South line. That's a tunnel project in Amsterdam, only 4 kilometers long. But you see here how the daily business on site works. There's one guy working, and 10, 11 people with their hands in their pocket are just looking. Nobody collects data. It's all practically oriented. And they go home at the end of the day, and nobody has learned, nobody has improved. The company doesn't have a system or data collected, and they don't have as-built information. So if you, after 5 years, would like to know what has happened there, nobody can tell you. That's a big problem in the industry, a lack of digitization. So this is where we are heading for, and this is our approach. Can you make it into? So this is how we see the industry in a few years. Just one guy having all kind of sensing devices, machinery available to improve. And we started with this idea. So in fact, on a watch on your wrist, you should have an overview of what's happening on site. You should have in one glance, you should have an overview of temperature gradients, maturity, compressor strength, project information, CO2 production, track and trace, your planning, your savings, operational stuff, your resources, and your quality assessment and quality control. We have this technology available because you have all kinds of sensors. IT guys can help you building up a decision support tool, as Dr. Blagiewicz calls it. It's just a portal to have all your information on it. And this is the way to control smart concrete in future. Also for repair or self-healing. In fact, on your wrist, you should see how self-healing your agent works in practice. So we have to work on that kind of stuff. I think that if we do not develop this kind of technology, that concrete will be a material of the past and will not help our society to improve in intelligent cities and infrastructure, etc., and buildings. I will go very fast through this one because it's a lot of text, but we started implementing remote sensing in the concrete industry by measuring compressive strength on a global scale in every standard. If it's ASTM, British standard, EN, national standards like the Belgian BNOR and Kiba, everywhere you see that people focus on the 28-day strength. In every standard it's in. But it doesn't make sense because in the last 2,000 years we learned that the concrete strength is maybe after 2 or 3 days on the right target that you need. So it doesn't make sense to press cubes, because a cube only tells you what the potential strength would be under a certain environment like water of 20 degrees Celsius. It doesn't make sense. You really have to know what's happening on site, how the structure feels. And the structure can tell you how it feels by sensing. And the structure can tell you how many cracks there are, or how many cracks already have been repaired, self-healing or whatever. And Andrea Blagiewicz will tell you more about sensors that we have developed for during service life. But this is where we are focusing on. And so we just started with concrete strength because I know that's the low-hanging fruit for the structure, for the industry. And as soon as we have convinced the industry to adopt this kind of technology, we can make the next step. To come up with all kinds of smart sensors doesn't make sense because our partners, our clients, are not that far yet. So you always have to take care of how does my customer, how does the potential user feel, and is he already at the intelligence or at the right level to adopt, adapt, and improve. Well, concrete and remote. How did we do it? We think, so we build up a system that you can use a sensor. Here you see a sensor. This is just the size of a sensor. It looks like a teapot. You put it on the surface of the concrete, and immediately you have real-time information. As fast as I do it now, you put the sensor on the surface, and immediately it tells you, hey, this is concrete, and this is the right strength, and it keeps on informing you. And at the right moment, it says, hey, you're ready. You can go to the next level, or the next story in your building, or the next phase in your bridge, whatever. So this is just a simple sensor, no buttons, no lights, and it helps you on a very intelligent level how to deal with your structure. So put the sensor on the surface, and like with your cell phone, the signal comes to your computer or your handy, helping you to improve. The only thing that we have to do, that we have to overcome in the beginning, is that we come up with a calibration. So once, when you start, you pour 5 cubes, you press them after a certain time, and during this period of 5 days, we monitor the strength development and we connect it to the real strength. That's it. So you create a fingerprint of your mix. It only costs you 5 hours over a time span of 5 days. That's it. And it's based on this principle. So here you see very fast how maturity looks like. If you have a certain concrete mix, and the hardening process runs for 10 hours at 10 degrees, 10 times 10 is 100 degrees Celsius hour. Huh? It's the same as if you do it 5 hours by 20 degrees. That's the principle behind it. And there's a more intelligent way of doing it by method de Vray, but this method is in every standard, ASTM, British standard. So we have looked for a global acceptance of this methodology, and it's already in every standard, but until today, not too many people have digitalized this. So we started this 13 years ago, and we are market leader on a global scale just by putting old-fashioned stuff in a new center. And this is what if you are looking for self-healing structures, you have to do the same. You have to monitor it. You have to be sure that it works. And you can do that with all kinds of algorithms, knowing your material. Because what you see here is we have, the C value of a cement is very important for that methodology. If you really want to know what the potential of a structure is and what the temperature development is, you have to know what the materials look like. And here you see SEM1, GGBS, or combinations. Well, in fact, that means that you will have, depending on the materials, a certain C value between 1.25 and 1.4. So as soon as you know what kind of material there is, you have a certain mix and you have calibrated the mix, you have the fingerprint of this kind of measuring. And I'm sure that also in regard to self-healing, there will be such a relation somewhere. So as soon as you have the relation, you put a sensor in, you can help your customer building up the trust in this new technology. Well, this is how this calibration works. I will not spend too much time on it, but we have developed new calibration boxes. So we send a box to the customer, they fill it, they press the cubes. 5 days later, you have this calibration curve, and that's what we call the fingerprint. As soon as you have this fingerprint, you see the maturity, temperature gradients, and the compressive strength. And that's really interesting. So real time, people can monitor their structure, can monitor the performance. What you also can do immediately is if you have 3 types of concrete, A, B, C, a fast one, a slow one, or one in between, you can evaluate what to do on site. Do I need a mix that helps me in 3 days, 7, or 14 days? Knowing that on a global scale, in 100% of the cases, 100% of the cases, concrete is too strong. the compressor strength is too high, 100%. So due to the lack of digitization, process control, quality assessment, we don't even know what's happening on site, and we focus on the wrong numbers. Because when you have a high strength, that does not mean that it's improving your structure. Then it's even more brittle than ductile. And I would like to have a ductile material that is flexible and not a brittle one.
And also bear in mind that when it's too strong, it's also too expensive, and the CO2 footprint is too high.
So what we focus on is use your mindset, look at the industry. We use a lot of cement. We use a lot of materials. We have to use less cement of a higher quality. We have to engineer structures with less volume of concrete. So the thickness of floors, beams, walls, whatever, it has to be a bit more tiny. Use less rebars, put it on smart locations, and measure continuously from beginning to the end. And I will tell you now something about the measurements during construction. And in half an hour, Andrea will tell you how we can measure during service life. And that could also be a possibility, quite open to you, to be used to monitor self-healing structures, repair, that kind of stuff. We have already had some contacts to industries who focus on repair works and on repair materials, because they are interested to use such a device and technology and decision support tool to improve their solutions. And here you can see, yes.
It's indeed it's a very good point. So your main focus now is on the compressive strength and the development of the compressive strength to monitor that. And indeed, in the SmartThings project, so there are 15 PhDs working on different topics, and one of them, Gabriele, he's in Cambridge. He will also work on sensing of damage and the disappearance of damage, how they heal again. So is that something you think is also an important aspect, that you really sense cracking and how that changes the behavior?
It's necessary, because times have changed. In the past, if you were focusing on a new mix design or a new material, you just did some tests according to the standards, and everybody felt happy with it. But first of all, it took a lot of money and time and energy to put all these tests out. Then it took a lot of time to get it into the standards or into the procedures. Afterwards, you can start convincing people, but it just takes too much time. And we don't, in our society, we don't have that opportunity, or that, how you said it, we cannot be too reluctant on that. It doesn't work anymore. So as soon as you have a new solution, put sensors in it and learn by doing. And that's your new approach of, well, R&D, I would say. It should be connected to sensing. So if your colleague is working on that, I'm open to start discussing this with him, and maybe we can help each other to improve this.
Yeah, sure.
So, and because then this happens, you see, okay, first of all, I have a certain planning in my industry. As soon as I start measuring, like we just discussed, I have these measurement results. I have all the information, and I can monitor the solution, the self-healing agent or the compressor strength or whatever. And then I can evaluate and measure and learn. And this is a circle that we have to do in a very, I would say, in a new way, by
actually every industry has that continuous improvement, but it's always based on data. And the construction industry oftentimes doesn't have the data, and thus no continuous improvement. And that's why they lag behind hugely.
Yeah. So this is our marketing strategy. Here should have all the benefits on your wrist. Doesn't matter if it's temperature, CO2, energy, propagation of self-healing, you should have it on your wrist. So make sure that you focus on this digital agenda as soon as possible, because then the user, the client or the customer can save time, increase safety, enhance concrete quality, and reduce its costs. In the building industry, if you look to the financial daily times in the Netherlands, the Financieel Dagblad, you can see that in fact nearly every contractor has problems to survive. Their productivity is low, and the failure costs are a multiplier of what their EBIT is on a daily scale. So really, our building industry has to develop.
And the construction, the opportunities are huge, because normally when you have these 4 KPIs, if you want to enhance one of them, you're going to sacrifice one of the other ones. In the concrete industry, you still have room to enhance all of them without having to sacrifice one of them. Big opportunity. Okay, practical, Toine. This was more or less the vision. Now, how are we going to do this? And you said before, the precast industry is more or less what you see now in the precast industry. You will see that in 10, 15 years time in the construction on-site industry. Mm-hmm. Where are we with these solutions in the precast industry?
Okay. Well, let's focus on the precast industry, and I do it. Let's do it first, because we discussed before we discussed the building on site. Let me show you something, a video. I hope that you can see it. Just somebody puts a sensor on the surface in a precast plant. Immediately, the heating starts. People just and the management sees the development immediately. So this is digitization, industrialization of a precast plant. Then, when the strength is okay, it stops, and you can take out the element. This is what you just saw. This is the overview of the plant. But make sure every beam here is 35 meters long. So this is a very large factory. And immediately when this sensor starts, the sensor opens or closes the formwork, starts the heating, and after a certain time it shuts down the heating and it measures the strength. So here you see, so this is position 1, it's open, no strength, no temperature. And then you close down the formwork, put the heating on and have a certain temperature. There's no strength yet, but after some time, the heating goes off and immediately you have some strength, 35 MPa. And after sometime you at 8 megapascal only, you can de-shutter, take out the element, and you can produce 2 or 3 times a day. So this is where we are focusing on, having the right mix and controlling the production to make sure that you have every day, again, the same quality, no cracks, no problems, use the right amount of energy, and you cannot open the formwork manually anymore. So this is also digitalized so that your risk, your failure costs are low, and it's also safe for your people to work in. So just by doing the things that you do on a regular basis in a more smart way, you have a lot of improvements for your people, for the product, your customer, and society. This is how we can reduce energy cost, reduce CO2 production, reduce material loss, etc. Here you see how it works. You just have sensors, and you can put them on fully automated sites. Here in Europe, in the Middle East, we do it everywhere. America, tanks. This is for Yapi Merkezi in Turkey for a big tunnel project. And maybe we can go to on site.
Yeah, let's speed up.
If you are on site, just put a sensor on the surface and immediately you see the results. And the sensors look quite simple. That means you have a cable sensor or a sensor on top or on the formwork. And that's to be developed for self-healing, I would say. People on site, they just do their daily routine. So you have blue and white collar workers, you could say. And these guys are focusing on the process, and the sensor here just helps them to give a red light going to green. Hey guys, you're ready for the next phase. But at the same time, and with the same information, somebody at the head office sees all the real data coming and knowing how to control or improve the process from a distance. We can even put some cooling or heating machines on it, so that when you, for mass concrete, if you measure the temperature in the concrete, we can speed up or slow down the heating by putting warm or cold water in polyethylene pipes in the structure. So we have a container with a heating and a cooling machine in it. We control the concrete on site, and this system of ours with these sensors, they control the container, and the container makes sure that the structure has the right temperature and strength development on the right moment. And the de-shuttering process takes place in the right follow-up. Some examples. This is, for instance, Tottenham Hotspur's football stadium. So we put some sensors in it. We reduced time, we have more safety and more quality control. And here you can see the example related to concrete technology. They started with a concrete mix with 400 kilograms SEM1 per cubic meter. We optimized it, and in the end, we changed their mix design, and we measured so that he has exactly the right strength at the same right moment, and reduced the cement to 273 kilograms and put some GGBS in it. And by measuring with these real-time sensors, we were able to help them in this optimization. Just doing the same as ever, only in a smart way, and saving money, time, and having better results. KTM Museum, same one. So it's all into reducing timing and making money with it, you know. So we try to give our intelligent concrete solutions to our customers so that they can improve, and that helps us, as Eric asked me before, to pay for my own internal R&D. So we try to earn money to make that happen. It's not easy, eh? I have a continuous lack of money over the last 26 years. This is, for instance, a highway in Doha, Qatar, and we saved on this structure 75 days. Then you talk about a few millions, eh? That's a lot of money. Tunnels. This is a dam in Canada where we put 1,000 sensors in it, only to improve. So, what are the customer benefits? Reduction formwork costs. We are quicker. We have real-time data, early post-tensioning, so it's also safer. Reduction of production costs, improving durability, because with a smart mix, you're more durable. We have grip on temperature gradients, so less cracks on site, and we have reduction of building time. Just on a higher abstract level, think about how this methodology or principle could help you with repair methodology or self-healing agents or whatever. It's the same, you know. It doesn't matter if you look at temperature, strength, or crack repair. It's the same principle. Huh?
Okay, good. Everybody still with us?
Yeah.
Any questions? I see some
So if
people
I understand it correctly, Toine, then these sensors, they actually replace those 10 workers, of those 10 people with the hands in the pocket at the north-south line. So you don't need them anymore. So it should go much faster the next time that they build a metro line.
We prove this. We do this on a daily basis on the largest project in the world. So we are working in Doka. That's a global, one of the two biggest formwork producers in the world, Doka and Perry. We work for Doka, and we implement our system on key and large-scale projects. Dams, electricity plants, power plants, bridges, tunnels, high-rise. Multi-billion projects where we are in just to help them. And it's just based on a simple principle. We try to be the best in concrete technology. We adopt, adapt, and improve digital technology and sensors and put it together. And then you can be successful. So if you would like to implement new technology in the industry in the next few decades, I think that's our conviction that this is the solution to help you. Because if you prove to the client that you're successful, they are willing to buy. Huh?
Eric, I think the short answer to your question is yes. You do help the company to do it faster next time. and simultaneously we help them to do it faster this time. So we always try to combine. That's why Toine, I think, make the split as well between blue color and white color. In the construction industry, by the way, blue color is oftentimes orange color. But anyway, that's on site, and they can do the right decisions at the real time. And the white collar people, they get all the data to have information for this continuous improvement.
Yeah.
So this combination is always there normally.
And the philosophy behind it is that we try to provide this information to both of them, blue, white, and orange color then. But it's all based on the same methods, the same measurements, without bringing new information to it. So only by measuring, that's enough. And we give them all kind of reports. And for this dam, for instance, that I mentioned, where we have put 1,000 sensors in Canada, we just send every day at 5 o'clock a report of the day before at 5 o'clock in the morning. The advantage is that everybody has the same data, real time. They start calling each other, not in panic, but just to say, hey, I see this, that, or that. How can we improve? Or should we change our mix? Or should we start up the heating? Because in Canada, it was the project was running under conditions minus 30 degrees to plus 30 degrees. So that's very serious, you know. So we started to heat up intense the concrete in wintertime, and in summer we reduced the cement content to reduce the temperature gradients, you know.
Yeah.
Okay, any questions again? You? Okay, so Toine gave, I hope, a good overview of our company and where we are now. Perhaps an interesting next question would be, and Toine, I'm going to ask it to you, what do you see as next steps? What comes after this? What are the opportunities that we see now?
We see a lot of opportunities. For instance, as I said, maybe you can zoom in a bit, Eric.
Definitely.
Very simple, just in a few bullet points. Improvement on a concrete focus. The hardening process is not under control. Never, ever. So in every building site, people are doing this on their 20, 30, 40 years experience. They pour some concrete and do some tests in mock-ups and tests, and they have their daily cube testing facility running. But in fact, they do not really know what's happening inside the structure, inside the concrete. Not in the core zone and not in the cover. And that's a problem, of course. And that we can solve that by using sensors. And as I said, the compressive strength is always too high in 100% of the cases. Due to the fact that they don't know these data and do not know what's happening, they just use more cement and choose for safety. Safety regarding strength development. But high strength means automatically brittle. And I would like to have a ductile structure. And high temperature means internal cracks, delayed Erdwin-Dijk formation and that kind of damage mechanisms. And high temperature also means thermal stress and cracks. Cracks reduce durability. And you have to see that in the global problem of producing 5 to 7% of the global CO2 emissions by concrete. So the concrete industry is responsible for 5 to 7% of the global CO2 emission. We really have a challenge. It's not a problem, it's a challenge. And we don't have real-time data. So if you put that up together, to me it's quite simple. Develop intelligent concrete and repair solutions or whatever. And at the same time develop sensing. Make sure that it works in a portal on a global scale real time, and you can help your customer. And you can implement all your new technology in this traditional industry.
Some last words of wisdom to the group?
Well, first of all, I hope that it was nice for you, because this was an alternative for a tour through our lab. If we go through our lab, it's much more appealing, I guess, and that's the reason that we just did it as an interview.
Yeah, and you miss on the coffee and cake now.
The coffee and cake, and that's we do it on another time after Corona, post Corona time. But yeah, well, as a resume, So we are a global concrete technology research center. Right? At least that's. Can you zoom in a bit? Because this is not easy to read, I guess. Huh? Yeah. So we are a global concrete research technology center, focusing on concrete, but concrete means rebars, couplers, fibers, and all kind of new healing, geopolymer stuff, etc. We really want to focus on this on a broad scale. And we are convinced that if you want to change the world, if you want to improve the industry, you have to transfer from reactivity to proactivity. So help the customers, help the industry, because they are working on their daily business. You know, they don't have time and focus to adopt this new technology. We really have to help them and show them what the result can be. And that means that we ultimately have to focus on industrialization of the concrete construction industry. And, well, we call it Concremode as a help desk. If you have real-time information, you know what's happening, you can guarantee quality and you can improve. And that's what servitization is all about. We call it servitization, a service and a product integrated. Concrete technology and remote sensors. And we are, well, it's quite helpful to us that internationally this industrial Internet of Things is developing also quite fast. So it's not difficult to find sensors for some solutions. Of course, it's not that easy, but this is the new approach, and there's a certain availability of this new technology, so use it. And as I said here, new sensors to create intelligent formwork, so not just wooden plates or steel structures as a formwork, but implement sensors in this formwork, implement sensors integrated in your structure, so that you have more intelligent formwork and structures, for instance. And this means that we develop new knowledge in a new domain with a new framework. And we call that not concrete, but funcrete. It makes fun to do it, you know? And we need the industry, our company, the society and our industry. We need smart, intelligent new guys that come up with new ideas and girls and are not afraid of this traditional mindset. We just have to help the industry overcoming this and make sure that also they feel that this is funcrete.
Okay, thank you very much, Tom.
Do you have some questions to us?
Yes, I see your hand.
Yeah, I do. I'm assuming the barrier would be the cost for this, the increased cost for this system. Do you know on average how much this would be? Because it's of course not just the concrete, it's just the whole system and the people who use it.
So your question is the cost of these new devices a barrier for our customers?
Very what? Sorry?
Is it the barrier for our customers? The cost?
Yes, yeah.
Shall I partly answer that one?
Okay.
Because that's a good question, and oftentimes it is. Our challenge is, I think, to explain to the industry that cost is only the one part of it, and profit is the other. So if your return on this investment is quite short, which it is in these cases, then in itself it's a no-brainer to invest in these systems. I think an even bigger challenge than the cost is probably the attitude and the general awareness of this industry of where they are as an industry, because they have a big problem in productivity and in failure costs. But because that's overall in the industry more or less the same case, they don't feel the pain yet. So that has to come. Yeah. Because if you compare it to other industries, that pain is definitely there. There's a lot of room for improvement, both on productivity and on failure cost reduction. And if that awareness gets better and better in the industry, then in itself it would be a no-brainer. Then you do invest in these things because it gives you the opportunity to reduce your costs. And if you look at margins now in the construction industry, it's very low. So the early adapters of these new systems, they will be the first who really going to make profits.
For sure. I think in a few years you cannot do without. And if you let's focus on a precast plant every day, they heat up their concrete. Even in winter, it's every day they implement a lot of heating systems. So if you use a smart system and you can reduce their energy cost by 100,000 a year, so the return on investment will be just a few weeks, not years.
Yes, sir.
That's the reason that we want to start with low-hanging fruit. I know that the compressor strength is not totally in grip. I know that they spend a lot of time, money, and energy, and we can. And as soon as you help them with that, with solving that problem, you create a. You could say they also create their own budget for further developments. So I'm not only creating my own budget in this company, but I also do it for our clients. And then your partnership grows, and then you will be the partner of these clients in their daily business. That's what that may, then the magic happens.
Good.
Okay, thank you.
Thank you for your question. More questions? Very happy to answer them.
Yeah.
Yeah, please.
Actually, two.
Yes.
Can you hear me?
Yes, ma'am. And we can unmute and see you.
Yeah. According to your presentations, I understood that you are looking into new technologies and getting into it. I want to ask, how do you forecast that a new technology, is going to be very fruitful in coming, let's say, 5 to 10 years? How do you take on the cues that a certain technology is going to be very money making in next 5 to 10 years? And my next question is, what are your views on self-healing technology? Because in the presentation on Wednesday, Will from Evercom, he had quite a few thoughts, and I want to know what your thoughts are on it.
So your first question was, how do we more or less assess which technology to start working on, because we think it's going to be a future advantage for the industry in 5 or 10 years.
Yeah, exactly.
Let me start with that one.
Yeah, that's a far time to look ahead.
That's very difficult. But that's also more or less a reason that we started with low-hanging fruit. The compressor strength, temperature gradients. We build up an international platform, as Andrea calls it, a decision support tool, and that's global available in different languages, according to different standards. So you just choose to say, okay, I'm somewhere in India, I work according the British standard, I work in PSI and not in megapascal, and language and that kind of stuff, and it works. And so now, just by focusing on a quite standardized topic, compressor strength, we are able to put new sensors in it and new modules. So we think that we can handle this by integrating, developing new modules. So it's a modular system. And for future, I'm focusing on an open source system. So that, for instance, when you come up with a certain new technology and sensing concept, you could put it in our system, or you could connect it to our system. Then we provide the global appearance and portal, and you come up with a new sensing device. So that's, our approach in overcoming this kind of difficulties. Is that clear?
Yeah. You mean to say we need to do all the testing and all the procedures before justifying a particular technology, right?
Yeah, but in connection to what we do. Yeah, and Andrea sitting here is eager to answer this question also in his next presentation. But this is the continuous combination between research, scientific research, and applied research. So as soon as you start up with a new technology, start measuring as soon as possible on some reference or pilot projects and learn over the data that you get.
And the other thing you need to do, to answer your question properly, and that's coming back also on the example that Toine had about the self-compacting concrete that we're using here, but not around the globe. and the time it takes to get that implemented in the industry. We don't have that time anymore because we don't have the outlook on what's going to happen exactly in 10 years. So your speed to go to market with new developments has to be very, very fast because you need a couple of years to get your return on investment yourself as well. And probably in 5 years' time, your own system will be outdated again. So that's one of the reasons we use this modular system to come up with new things on a very continuous basis. And we have to make sure that in a few years' time, we can more or less earn back our investments because it has to be very fast. Because now, hopefully, the industry is going to develop and take off. In the past, we could take 20 years to get a return on investment. That's too late now. And perhaps to your second question, I think you as a group, you can be, you're lucky that we as a company, and that goes for other companies as well, we have not been able yet to make sure that this prevention, what we're doing, to make sure that the quality of the product is perfect. It's not going to happen. So because of that, we might still need maintenance and repair and self-healing concrete. Actually, we're trying to make that not necessary. We're trying to make a product that is so good you don't need to repair it.
Yeah, at least.
But we won't succeed, so you're good to go.
Reduce failure costs during the building time, and reduce the asset management costs by predictive maintenance. And that brings me to the next presentation. But are there other questions?
Yeah, I have a question. So it's something more practical. I saw in one of the videos that you showed the person working in the precast industry, they themselves place the sensors and perform the measurements. Do you normally teach them or demonstrate the usage of the sensors on the site, or is it an easy approach that we don't need experts to directly use the sensors, because not everybody is well trained in using your technology and the instrument itself? So what is your approach, and what do you see would happen if we are going to do it on site with other workers?
Yeah, that's a good question. We try to make it as easy as possible to use it, and what actually happens in the current situation is that we sell our product, our system, to a customer. And of course, we have discussed it up front already, and they have had some information. But when we go actually on site to install the system, we send one guy over for 1 day to train the people, and that's it. And then, of course, we have a support desk that they can reach 24/7. But in itself, that 1 day of explaining how it works, that's sufficient. That works.
So that's also I say that a demand. When you start this kind of stuff, don't make it complicated. So come up with sensors that are quite easy to use. Otherwise, you will fail. You know.
That's also, by the way, something that has been developed over the past years, and you're all quite young. I'm not looking at you, Eric, but I remember buying my first mobile phone 20 years ago, and I got a booklet with it, with how to use it. If you buy a mobile phone nowadays, which can do 1,000 times more, it's self-explanatory. That's how it works nowadays, and that's how we set up our system as well.
Yeah, so you meant to say it's basically user-friendly and you don't need much experience prior.
We could give you a system and give you your login data. We would spend an hour on the phone and you would be able to operate it.
Okay.
Anywhere in the world.
That's good news. Thank you.
For other people, we would use 2 hours. But
For you, only.
Yeah, sure. Thank you.
Thank you. More questions? Because I think, Eric, and now I am looking at you, that a break is planned now, which I can imagine you would need after listening to us for an hour.
I think a break for maybe 15 minutes would be good, and then that Andrea continues then.
Yeah, and Andrea is going to continue.
Was this what you more or less expected, or?
Yeah, this was perfect. I would like to thank you very much for this, because it was really almost as good as visiting the lab and being on site. So you really did a very good job of presenting the company and what you do and what kind of projects. I think it was perfect. I liked it a lot. So thank you very much.
Thank you, and I hope that you enjoy the rest of this setting, and this is the last day, isn't it?
Yeah, it's the last day of our training school week, so yeah.
Okay, well,
I think they are quite tired, but yeah, I think this was different from the normal lectures that we had this whole week. So this is really applications and what you do within a company and at a very high level. So that's very good to see. So that's,
okay, that was our goal to make it a bit more dynamic. Well, thank you very much for listening. Good luck, and I hope that you have a nice hour with Andrea. He will prepare now. So at what is it? 11:30.
Yeah, 11:30. We continue. Yeah.
Thank you very much.
Okay.
Ciao.
And please note, after Corona, you're always welcome in the lab here to visit
Exactly.
in person.
Perfect.
Ciao.
Bye.
Yeah.
Ciao.